Thank you for tuning into my presentation about trough orientations and their relationship to significant tornadoes across the United States. This was, of course, a project for Computer Science 270, so hopefully this isn't too meteorology related, but if you don't know what a trough is or the criteria for a significant tornado, I'll provide some context going into this research presentation. So, of course, to start off, what exactly is a trough? Now, a trough is a southerly dip of the jet stream, which usually brings some strong upper level winds to the mid latitudes, so across the United States. And what does that mean? That might mean more active weather, more cloudy weather. And as you can see depicted in this lower figure, we have this satellite imagery showing a dip in the jet stream. If you follow it, goes all the way south and eventually pushes eastward across the East Coast. And as you can see, the center of the trough is right about here. And a lot of this cloud cover is on the right side of it. And the center of the trough we call the trough axis. And we see most of the active weather actually on the right side of it because we have a lot of upper level divergence occurring over there. And don't get too caught up in the term divergence. Basically, if we have upper level divergence, we're going to see more cloud cover. Now, if there's sufficient moisture at the surface, along with strong lower level winds, usually associated with the low pressure system, such as a mid-latitude cyclone, there exists the potential for severe weather, and that also includes tornadoes. So just a little bit more on troughs. We have different classifications of them. We have a positive trough, neutral trough, and negative trough. What does that exactly mean? A positive trough has this center or this trough axis that tilts westwardly. Of course, a neutral trough has a trough axis that is oriented vertically, north to south. And a negative trough has an axis that tilts easterly. And now that we know we have different classifications of these troughs, can we determine what type of trough is more likely to produce a significant tornado? And using that information, can forecasters use that as a metric to determine the potential risks of an upcoming severe weather event, if it may lead to more significant tornadoes? Now, I've been talking about significant tornadoes a lot. What exactly is that? So, a significant tornado is a tornado with a rating of EF2. EF, of course, stands for the Enhanced Fujita Scale, developed in 2007. And that means there's going to be winds of 110 plus miles per hour. And that's definitely going to cause some significant property damage. Now, I made this metric called Days with Significant Tornado, or DST, and that's basically going to keep track of what day had an EF2 rated tornado. And I looked through January 1st, 2007, all the way through December 31st, 2024, and using the NOAA Storms Event Database, I was able to determine that there were 740 days with the EF2 plus rating of a tornado. So it could be EF2, EF3, EF4, EF5 tornado. And of course, 740 events occurred. Now that we know the exact day that those events occurred, we could delve into the more atmospheric science side of things and start looking at 500 hectopascal geopotential height. I know that sounds like a big word, but this is how we're going to determine what type of trough we have, because we use these plots to determine the trough axis orientation. So what I did was I looked at the single level ERA5 reanalysis, and that's basically a model reanalysis produced by the European Union or their Weather and Climate Agency. And basically using all the days that I found those significant tornadoes, the 740 of them, I pulled NetCDF files and plotted the 500 hectopascal geopotential height. And now that can help me determine or classify the troughs into 4 different categories: the positive trough, the neutral trough, or the negative trough. And I do also have this other category, and I'll get to that in just a minute. So here's an image of what a lot of the classifications looked like. The red dot shows in the tornado report. So in this image, we have a negative trough as the trough axis is pointing eastwardly. And this, of course, has a tornado report on the far western edge of Illinois. And this depiction of the trough is actually a positive trough as it's pointing more westerly with height. And we have a tornado report up in Michigan. And right here we have a neutrally tilted trough. The trough axis is directly north-south, and we have a tornado over in Louisiana. And now comes this category, the other category. And right here, there's not really a trough you could pick up on. And what this actually is Hurricane Helene back in 2024 in September. And of course, with Hurricane Helene, we did have tornadoes that were produced because of that hurricane. And that's a common occurrence. We get a lot of tornadoes with hurricanes, and we get tornadoes in areas that there isn't really a trough. A trough is just useful because it increases the ingredients necessary to produce a tornado, which is wind shear. But we don't need a trough exactly to get a tornado. It's just usually pretty helpful to have one. Now, getting to the more statistical side of things, here is the data that I was able to pull after sorting through all 740 of the days with significant tornadoes. You can see we had 185 days that produced a significant tornado that were during a positively tilted trough. And we had 168 days of significant tornadoes that produced, or 168 days of significant tornadoes that were during a negatively tilted trough. And we had 211 days that had a neutrally tilted trough, and then also 176 days that were classified as other because either it could be a hurricane or just the tornadoes weren't associated with the trough. So just looking at the numbers blindly, we definitely see that there is a clear favorability towards significant tornado days and troughs. So like approximately 76.2% of tornadoes did occur within a troughing pattern. And yeah, that shows that significant tornadoes tend to occur when troughs are present. We already really knew that. But what I was trying to find out was the different classification of troughs. Do those have a favorability towards producing significant tornadoes? So I used a chi-squared test with the significance level of 0.05. And using that significance level, it showed that there isn't much of a significant bias towards certain trough orientations, meaning that significant tornadoes are just as likely to occur in positive troughs, negative troughs, or neutrally tilted troughs. But if I did increase the significance level to maybe 0.1, it did give me a p. Of course, the p-value was 0.08, so it gave me a p-value less than our significance level, meaning that there may have been a slight bias towards maybe negative troughs producing less tornadoes and neutrally tilted troughs producing more tornadoes. But for my purposes, I'm going to just stick to the significance level because that's a common practice of 0.05. So if there's no clear favorability towards any specific trough orientation and significant tornadoes, what can we look forward to? Like, is there any more research that could be done with this? Well, I would like to see if there's a more significant distribution in the trough orientations when we're looking at a smaller geographic area, because I looked at the entire United States. But what if I looked at tornadoes that only occurred maybe in like the northern plains of North Dakota or like the southeast region of the United States, because different places in the U.S. tend to have, or I should say, when I was actually looking through the data, I started to notice that, oh, the southern plains near like the Texas Panhandle and western Kansas, it seemed like a lot of the tornadoes over there were occurring when we had a negatively tilted trough. And maybe that has, maybe that could occur over in the East Coast throughout the Ohio River Valley. Maybe I could find that more positively tilted troughs tend to produce tornadoes out there. Now, of course, it would be great to do more research with that, but a big problem I found was I had to go through 740 troughs, and that was just between 2007 and 2024. And if I wanted to expand my data set down to like maybe even 1950, I need a better way of sorting and classifying those different trough characteristics. So can I develop an algorithm that could sort it for me? Maybe I could use random forest with machine learning to pick apart the different trough orientations, but I think that would make the research go a lot faster and maybe reduce the human error and biases that I may have had when sorting the different troughs for those significant tornado days. But other than that, I just want to thank you for watching my research presentation or my final project presentation. Of course, I'll just leave you with some satellite eye candy. This is actually some supercells producing some tornadoes out in Missouri and Illinois and Kentucky from today, which is, I think it's like May 16th. But other than that, have a great evening, and thanks for watching.